So let's take a look at this problem now that changes things. So far we've worked with area as far as our probability is time, probability with degrees. Now we're going to look at probability with geometric spaces, which is what's the probability that if I randomly land somewhere on this figure, that I'm going to land inside this blue ring and not inside this pinkish ring. Nothing yet. Think of it from the same way we handled it before. The definition of probability says the probability of any event happening is the number of ways it can happen that I want divided by the total number of tries. So what I'm really asking here is what's the area of the blue ring divided by the total area? And this is where that composite stuff we worked on last section comes into play. Let's see, it says the outer radius, that's this radius here, is 5 units. The inner radius, that's this radius, is 3. I'm going to leave my answers in terms of pi to keep the math simple. Probability of the whole target of the, let's do pi, let's do area. Area of the whole target is going to be pi times the radius squared, right? So that's going to be 25 pi. What's the probability of the area, not the probability, area, of the pink part? That's pink. The middle circle is pink. Oh, maybe it looks brown or tan to you guys with the way this is. It's pink over here. What's the probability of that inner part? I'm sorry, the area of the inner part. 36 pi. No, not 36. 9. I don't think it's going to work out to be 30. Is it going to be 36%? We'll see. So the area of that inner part is going to be 9 pi, right? So what's the area of the blue disk? The blue ring around it. That's the total area, 25 pi, minus the cutout, the middle, leaves me 16 pi, right? Who have I lost already? Let's go back and find you. This first, let's kind of recap. This first item, that's the area going all the way, that's this whole thing, the whole circle. It's 25 pi. The inner part of it, this region in here, that's this 9 pi. And then I subtract them to get the blue ring going around it. Now the question was, what's the probability if I hit the circle, I land in that outer ring? So to do that, I say, all right, well, let's see. The area of the blue ring is 16 pi divided by the total area, 25 pi. And that works down to be 16. The pi's cancel. 16 divided by 25 gives me 64. So 0.64 or 64%. That's it. The whole trick to these geometric area probability problems are to find the area that you want to land in, find the total area of the place you're going to be landing, and then set up a fraction like you do for any other probability. So again, it's a lot of stuff that we worked on before. It's just bringing it all together now in a new kind of way.